All right, so you got your answers here. 29. What are the two functions, Hayden?
Fx equals 3x plus 1
And g of x,
is x minus 1 over 3.
like this. Is that right? All right, this was important because it's how you show your work for this one. It says verify their inverses. If they are inverses, okay, then f of g of x has to equal x, and g of f of x has to equal x. Okay, so you know the answer. Okay, they're saying verify, which means, okay, those two are inverses, but you got to show me the correct math. It's not like crazy difficult for this one, but I still need to see it. So for f of g of x, take this, and that goes in for the x. So you got 3 times x minus 1 over 3 plus 1. Two ways you can do this. What can I do with the 3's? You can cancel them. If I cancel them, that just leaves me x minus 1 plus 1, which is just x. Okay. The other way, I'm just going to stick with this one here because, I don't know, half people do it one way, half do the other. So if I get 3 times x minus 1 over 3 plus 1, what's it look like when I multiply in by 3? This is where a lot of people do this incorrectly. You only multiply 3 times the numerator. Do not multiply it by both of them. So when I get this, it gives me 3x minus 3 over 3 plus 1. Then you can just kind of simplify here and make that 3x over 3 minus 3 over 3 plus 1. That just gives you x minus 1 plus 1, which is x. That way it's probably a little messier. Still get the same thing. So I'm not sure if you cancel the 3's or distributed it. Biggest mistake is some people make this a 9 because just doing that incorrectly, multiplying 3 times both of them. Do not do that. I think the other part's a little easier. So g of f of x. That is, so you take this, 3x plus 1, plug it in for the x. And that's over 3. And then plus 1 minus 1 adds up to 0. I end up with x. Okay? So that's going to be the case there. Anything else? Good one. That's a good question. All right, we're going to finish up, and then we're going to start kind of get you going, starting to review for the test of the Monday, Tuesday test. Okay. Sunday night, I will do a review session, like a Google Meet. I'll send you out a link. It'll be on Canvas. I haven't set it up yet. I'll let you know for sure tomorrow. I am not going through any content. It will not be if you have questions or if you want me to go through a problem. That's what we do. If you just want to get on there and see what other people ask, that's fine. But I will not be presenting any, nothing. It is for questions only. So I'll do that at 8 o'clock for as long as people are on there. Okay. All right, let's finish up a couple things here on these notes. And then I'm going to give you some time in class to work on a couple things here. All right, copy this down for the that second one there. I believe we're like a little bit above halfway. Keep going all the way in the back. Nope. I lied. Right there. Okay, sorry, I thought you were all the way in the back.
I have notes from yesterday.
Yes. All right, now this says verify. Verify means that these are inverses. I'm staking that claim, so when we plug it in, we should get right back. Okay. X, so you got to show me that. Now, for the sake here, we're not going to prove them both. Technically, I need to show that f of g of x equals x and g of f of x equals x, we're just going to do one. Okay, we're just going to do f of g of x. Okay, just for time's sake. So we substituted in. You got to show me the math. You got to verify that it's going to just simplify down to an x. All right, this one's not as nice. So what does f of g of x look like? Okay, so 2x plus 1 over x minus 1 is going in for each of the x's. So 2x plus 1 over x minus 1 plus 1. 2x plus 1 over x minus 1 minus 2. Now, we've done a couple problems like this. We've talked about there's two ways you can go about this. You get a common denominator, or you can multiply by get rid of fraction. Let's multiply to get rid of the fraction, which means I would multiply both of these by x minus 1. Okay. What does that give me on the top when you go through that? Brandon, what do you think?
2x plus 1 plus 1, then parentheses x minus 1.
Okay, good. This x minus 1 that cancels with that, and so you're left with the 2x plus 1 plus 1 times x minus 1. And in the denominator, same idea. This x minus 1 will cancel. You're left with 2x plus 1 minus 2 times x minus 1. See, then the top one, since it's just a 1, you would just be left with what's in the parentheses. But if there's a constant there, then you have to distribute that constant. So whether you do this in 2 steps or do it all in one, it doesn't matter to me. But I just need to see this is going to be 2x plus 1 plus x minus 1 over 2x plus 1 minus 2x plus 2. Then on top, okay, I'm just left with what? 3x. What am I left with on the bottom? 3. So I get 3x over 3, which is just going to be x. Again, you're being told that those are inverses, and you're asked to verify that, which means when I take f of g of x over g of f of x, I get back x. Okay, so that's how you verify. All right, to this point, I've told you the two functions are inverses. Now we're going to go to the point where we find an inverse. Okay, so find the inverse for f of x equals 3x minus 12. And the domain is going to be important for these type of problems. Find the domain range for both the function and the inverse. All right, so we need a function. So when I'm going to do a couple things here. Don't write these down. What is f of 5? F of 5 equals what? 3. 3 times 5 is 15. Minus 12 is 3. The inverse, what's got to be true? F inverse of what? Let's make sure we're Adam. F. What's going to happen with the inverse?
The inverse would be f inverse of 3 would be 5.
F inverse of 3 equals 5. I got to come up with a function. When I plug in 3, I get back 5, right? All right. Do you remember how to find the inverse for something like this? Okay.
Don't you plug the y into where the x is and plug the x into where the y is?
Yep. You replace x's, any x with a y and any y with an x. Okay, we'll start with that. First thing though is if it's written as f of x, go ahead and rewrite that as y equals 3x minus 12. So you got that. Once it's written like that, okay, what you want to do is you want to replace all x's with y's and all y's with x's. And really what you're doing after that is you're going to solve for y. So we're going to flip everything. So you remember about inverse functions, we said like if xy is a point on the function, then yx is a point on the inverse. Like everything flips. So we're going to do that. So in this case here, this y becomes an x. This x becomes a y. and we just have to solve for y, get y by itself, good old-fashioned algebra. Okay, so we want to do that. So x plus 12 equals 3y. Divide by 3. And I'm going to write the y first. Y equals 1/3 x plus 4. Now I'm just going to write, so my original function, what was my original function? 3x minus 12. 3x minus 12. And just using proper notation, f inverse of x is 1/3 x plus 4. Okay. All right, domain and range. Take a second. I want you to look at it. Don't write anything down until you know for sure. I'm just going to write this down. Domain of f, range of f, domain of the inverse, range of the inverse. All right, Matthew, you think you know him?
I think so.
What do you think?
For the domain of f, all real numbers.
All real numbers. I'll agree with that. I'll agree with that. What else you got?
The range of f should be all real numbers.
Okay. Domain of the inverse?
All real numbers.
Okay. And range of the inverse, all real numbers?
Yeah.
All right, now there's nothing crazy going on with these two. What's it? 3x minus 12 look like? It's just a what? It's just a line. It's just a line. Okay? And so it's going to go, there's no radicals, there's no division by 0, so there's nothing we can't plug in. And a line is going to go, unless it's a horizontal line or a vertical line, is going to go have a range of infinity as well. So there's nothing, I just want to make sure you're good with that. Nothing goofy happens here. All right, flip it over on the back. I think that's where we're at. All right, now these next two get a little trickier. I still want you to find the domain and range for both. At this point, what's the domain for the function? Okay, Justin, what would be the domain of the function? Everything but what? Everything but 0. Okay, because 2 divided by 0 is 0. Doesn't matter about that plus 5. Everything but 0. We'll list it in a second. All right, so let's go through the process. I'm going to write this as y equals 2 over x plus 5 to begin with. Everywhere there's an x now, I'm going to take it out and put in a y. And everywhere there's a y, I'm going to put in an x. I don't know if I worded that correctly. All right, so it's going to look like this. X equals 2 over y plus 5. Solve for y. All right, what's your initial thought? Matthew?
Subtract 5.
Okay, subtract 5. Anybody else think something different? You could also do what? You could also multiply by y. We're eventually going to have to, but probably subtracting by 5 is the best way. Gives me x minus 5 equals 2 over y. All right, from there, Ollie, what do you think?
Multiply both sides by y.
Yep, multiply both sides by y. Tell me what to write, Anthony.
Yx minus 5y.
I'm just going to make it xy. Equals what? 2. Okay, now where do we go from here? Matthew's got a little confused look on his face. Carter.
Never mind.
Oh, come on. Good.
You add 5y.
No. Because where are you gonna go with that?
I was gonna add 5y and then, now it's gonna be just 5y and we get x equals the numbers.
And let me do that just because I see this all the time. XY, if I add 5y, 2 plus 5y, and people say, I'm going to divide by x. Why can't we do that? Because there's still a y over there. Anna.
Instead of putting the y into the x minus 5, I just put it on the outside and put the x minus 5 in parentheses.
Okay.
And then I divided the x minus 5 over 2.
Yeah, this is one of those cases where Anthony multiplied through, but then after that, we're going to have to factor it back out. Okay. Sometimes you absolutely have to multiply it through. You can't get away. But here, you got 2 y's, you got to factor it out. So now I can divide by x minus 5. So yes, that would be the case. So y equals 2 over x minus 5, which means that the inverse function equals 2 over x minus 5. All right, so let's see here. What was my original function was 2 over x plus 5. My inverse function, what did I have for that one? That was 2 over x minus 5. 2 over x minus 5. All right, we still need to list domain and range. The domain of f range of f domain of the inverse range of the inverse. All right, Justin was kind enough to tell us the domain of the function. Everything but what? 0. So it's negative infinity to 0 union 0 to infinity. All right, before I even look at the range, what's the domain of the inverse? Marissa. Wait. Did I ask for domain of the inverse? Domain of the inverse. What can x equal there?
5.
5. So everything but 5. Okay. So that's negative infinity to 5 union 5 to infinity. Well, we had several people go on yesterday, so hopefully you went through the lesson. But how do you figure out the range? Because at this point, you cannot just look at this and tell me the range. So, Andrew, you remember how we do it? Thought that was a hand.
I just graphed it on the calculator.
Oh, you graphed it. Well, there's an easier way. Matthew.
I would disagree with your statement that you can't just look at it and find the range.
Oh, okay.
Because
Nice.
listen. Because x can't equal 0,
Right.
you can just look to the equation and see that the y-intercept is at 5. And since the y-intercept is when x is 0, then it can't be 5.
Will that always be the case?
It's not always going to be the case, but for this case it works.
So in this case, it works. So.
That's what I was thinking too, man.
Interesting. Anna.
Or you could say that the domain of the original equals the range of the inverse, and the range of the original equals the domain of the inverse.
All right, so yeah, that's where I was going. Matthew, you can stick with that. Here's the case. These two have to be the same. Okay. The domain of the inverse is going to be the same in the range of the function. And as Anna said, the domain of the function will be the range of the inverse. Because we talked about how when you graph it, you go from x to y, and then you take that y value and you plug it in and you get back x. So once I know this, and I guess you can go your x-intercept route or y-intercept. But this is going to be negative infinity to 5 union 5 to infinity. And this is going to be negative infinity to 0 union 0 to infinity. So the range is a little bit harder to visualize. The domain, you guys cannot have a 0 in the denominator. You cannot have a negative under the square root. But that's always going to be the case. Those are the facts we really went over yesterday. And so we're just going to apply them a little bit today. Let's take a look at one more. We're going to find the inverse. So like we're going to do a couple that are a little bit messy here. We're going to take the f of x out. We're going to set it equal to, or let that equal y. 2x over x minus 1. Now we're going to do that flipping. Everywhere there's a y, you're going to make it an x. And everywhere there's an x, you're going to make it a y. All right, go ahead. I want you to think through that. Think through how we're going to solve for y. Okay, in terms of that. So I'll go over in here in a second. I don't know if I did attendance. We'll see if Matthew's little trick works again. I'm curious. All right. Now, how are we going to take care of it? Hayden Crozier, what do you think? What you got planned?
I multiplied the y minus 1 over to the other side.
Okay, y minus 1, because you can't have a y in the denominator. And let's just start. I'm not even going to distribute it yet. I'm just going to write this as x times y minus 1 equals 2y. The last time we got away without distributing it. Can I get away with it this time? No, you have got to distribute the x because I got to get that y out from that parentheses. I cannot move it anywhere at this point. So you do have to distribute. So I get xy minus x equals 2y. All right. There's two ways you can do this one, and whatever way we choose, I'm going to show you the other way just to make sure we're good with it. Not that you have to do them both. All right. What are you doing? Adam, what are you doing from here? Or are we done?
Oh, we're not done.
Oh, thank you. That's whew. Okay. So we're right here. What are you
sure?
Not sure? Why aren't we done? Maybe I can ask that.
Y has to be by itself on one side.
Okay, on one side. All right, don't do this. Can you just divide by 2 and call it a day?
No, still have y on the left.
All right, good. We got that y on the left. That's a problem. You can't, it just has to be a single y equals. So you cannot divide by 2. So I got a y on the left, I got a y on the right. Hayden?
Subtract the xy over.
He said subtract the xy over. Wherever, if you got whatever terms have a y, remember they got to be on the same side. I'm going to subtract xy. And that gives me negative x equals 2y minus xy. Now here's why this works. You get everything with that variable on the same side. Then we do what? Factor it out. You can factor it out. And so I get negative x equals y times 2 minus x. Now I can divide by 2 minus x, divide by 2 minus x. And I'm just going to write the y first. Y equals negative x over 2 minus x. There's your inverse. There's your inverse. Now, depending upon the problem, some people will do it slightly different. Just pay attention to this. Hayden said to subtract the xy. Sometimes people will say, I'm going to move the 2y over here and move the x over here. I just want to show you what happens. So what happens if I subtract 2y? And then what happens if I add x? Okay, that gives me xy minus 2y equals x. I still factor out a y. I still divide by x minus 2. Now, are they exactly the same looking at them? No, but they're equivalent. Why are these two equivalent? Like sometimes, here's the deal. Like if you get this answer here and the answer in the back of the book is that, some people say, well, I got it wrong. I don't know what I did wrong. Well, they're the same. How can you tell they're the same?
if you factor out a negative on the one right there, it equals
It actually got factored on negative out of the top and bottom. And here's why. Just take a look at it. All your signs are opposite. If they're all opposite, then it's the same thing. That's a negative x. That's a what? Positive x. That's a positive 2. That's a negative 2. Negative x, positive 2. So what I'm getting at, if somebody comes up with an answer like y equals 3x minus 5 over 5 plus 2x, whatever, and somebody else says, oh, I got negative 3x plus 5 and negative 2x minus 5, what can you tell me? They're the same. They're the same. Yeah, and you don't need to try and make one into the other, because as long as everything is opposite, really you could factor out a negative 1, they cancel, everything's good. All right, so that's our answer. I don't care which way you write it. We wrote it this way. We'll keep it this way. Let's think domain and range. Let's think domain and range. F of x, 2x over x minus 1, f inverse of x equals negative x over 2 minus x. Domain of f. Oh, that's an f there. Range of f. Domain of the inverse. And range of the inverse. Okay. All right. Domain of the original function. 80. What's the domain of the original function? Or what can it equal?
0?
We looking at the same functions?
No.
Original function, right here. Denominator can't be 0.
Oh, 1.
There we go. Positive 1. So your domain is negative infinity to 1 union 1 to infinity. Okay. Now that's going to be the same as what? Let's see. How about is Matthews
No.
working?
Definitely not.
No, definitely not.
It was just a case by case basis.
Case by
I
case.
got lucky last time.
All right. So I just double checking. Sometimes that's how you figure things out. All right. Well, all right. Domain of the inverse. Let's just jump to there. Marissa, domain of the inverse.
Negative infinity to 2. And 2 to infinity.
Negative infinity to 2, union 2 to infinity. Okay, so now, domain of the inverse is going to be the same as the range of the function. And so that's going to be negative infinity to 2, union 2 to infinity. For those of you who weren't here yesterday, that's one of the properties we went over. Okay. And then domain of the function. Whoops, I want yellow. That didn't work. Oh, crap. Dang it. There we go. There. Let's see if we can get there. All right. So that was a long way to get there. And so that's going to be the same. Negative infinity to 1, union 1 to infinity. All right. All right, here's what I got for you. I got 2 things for you. All right, you're going to do page 304. 43B, 51B, 59. You're going to get that done before the end of class. Okay, that's classroom. You don't need to turn that in. You just need to make sure it's correct. I do have an answer key in Canvas, as well as you can ask me or check in the back. I do want you to find the domain and range for 59. I'll explain that again. Then, once you're done with that, there will be a review sheet that I'm going to hand out to get started on reviewing for the test. Okay. This will not be due tomorrow. I'm going to give you some time in class tomorrow to work on it, as well as some additional problems. All right. Plus, Sunday night, I'm going to give you as much as I can here for this test. So, if you're not doing something or it's not, working out, you got to check your problems or check on that Google Meet. Work on this till the end of class. If If you want to work on it and get ahead tonight, that's fine. It's not, it's not gonna, doesn't need to be done until tomorrow. Do these problems to begin with. I'll hand out that review sheet. Check them. Make sure you got them right. Questions? All right. Good. Let's stop that. Let's